We're on the garage north exterior wall. This is the electric meter by two of our condensing units. The electric meter should have been sealed like all our condensing unit disconnects. All of these boxes should have been sealed on three sides, the tops and the sides, to help prevent moisture infiltration into the water. The power's coming in below grade. That's a really good thing. Now, what they weren't doing 30 years ago and they're doing now is they're adding slip joints to this electric power supply conduit to relieve the pressure from the box when the ground and the structure moves. So it doesn't have that. I'm going to write that you don't have it. It wasn't required. Now the grounding rod, okay, it's supposed to be buried. That's an 8-foot grounding rod. It's supposed to be buried 8 feet, not 7 foot 6 inches. Now, an electrician can come in and put a meter on it and demonstrate to the code inspector that you're getting enough resistance and that it's not necessary. I wasn't here for any kind of special meeting for that. All I know is that the code in and of itself, without the conversation between the electrician and the code inspector, the code says that it should have been buried. And by today's code, you shouldn't have two grounds within 6 feet of each other. So we only have a single ground, which is typical for the time, day, and age. Got a single ground, and also that one's not buried. The lawn sprinkler head shouldn't be closer to the structure than 5 inches, and our water heaters temperature pressure relief valve drain piping should discharge no farther from the ground than 6 inches. Those discharge too high. But I said the meter should have been sealed, should have had a slip joint, the grounding rod wasn't buried, and we don't have a second ground on the north exterior wall. Now we're going to go around here inside the garage into the north interior wall. This is where we're going to find our meter, and we're going to find that we do have a main principal. Okay, that's good. We're supposed to have one of those. But you know what we're not supposed to have? We're supposed to have one outside. And we look at this a little better. And then we find these things as L1 and L2. They're supposed to be protected by a non-conductive cover. If you don't know that's hot, you don't belong in this box. And then we look at these strands. See, this is cable. Okay, and then solid, that's wire. That's a wire. Take a bunch of wires together, put them together, you make a cable. The thing about electricity, okay, it moves like water. So when you study the principle of electricity, it's kind of like plumbing. So we're studying the movement of the water. That being said, the electricity doesn't go inside of these wires, it goes around the outsides of these wires. So when these wires are chipped like that, that changes the rating of the cable. It's not supposed to be chipped like that. When it's chipped like that, it's not supposed to be chipped like that. It's supposed to have a non-productive conductive cover. And then, see this? This is handwriting. See where it says main? Okay, that's printing. Now, I didn't wake up this morning wondering how I was going to piss everybody off and say, you know what, I'm tired of looking at all that handwriting. I'm just sick of it. I want to say that it needs to be printed. No. The National Electrical Code says that that's supposed to be printed like it says Cutler hammer. No. The International Residential Code says that it's supposed to be printed like it says load centers. Okay? No. Cutler hammer Eaton says that it should be printed like Eaton. So the manufacturer says that it should be printed. Now, is that going to change the way these breakers work? No, probably not. We've got some of them that are labeled here. And we're coming on along the side of here, and we're also looking at, we've got colors. Ooh, nice colors. Okay, if you don't know that's a white hot going to an air conditioning circuit, you don't belong in this box. I get that. But these should have been wrapped with black tape. Or painted black or something, but you should not have white, exposed white hots like that. You just shouldn't. Now come over here a little bit farther. Now you got these neutrals. These are not white hots, these are neutrals. But like white hots, if you turn the switch on, electricity comes out of here because it's been called for, goes through the light, comes through here, comes there, goes to the ground, goes to, it makes a complete circuit, and everything works, and everybody's happy. And that's the way it works. You'll notice that all these circuit breakers have one wire for each circuit. They have one screw holding these wires. Okay, these wires is this If this is on and this is on, okay, you got a light on, you got a fan on. They're at different times. You turn one of them off. You got different heats and cools, a different, big fan, little fan, computer, whatever it is. You got the different ratings coming through here, heating and cooling at different times, and one screw holding it. And then all of a sudden it gets loose. It works its way loose, and all of a sudden you don't have power. Maybe sparks, but usually no power. But anyway, that's called double lug neutrals. You can double lug a ground. You can double lug a ground. Alright? Why can you double lug a ground and not a neutral? Because grounds are there for an emergency. Neutrals are there. We expect power to go through them all the time. Let's go on in here and see what else can we see with these grounds, though. We're not through looking. Oh, there's one. You got 3. You can double lug a ground. In some cabinets, you can triple lug a ground. We got a little bit of triple lug in there. That's a cable. Okay, we're just going to leave that alone. But we're going to call this double lug neutrals, that's for sure. We got white hots. It's not properly labeled. The bonding location is on the upstairs, in the attic, in that attic. The water heater is on the right side. The north water heater is the bonding for the electrical system. So that's where you're going to find your bonding. So that's what we learned. We learned that our panel wasn't properly labeled, bonding wasn't labeled. We got white hots. We've got double lug neutrals. We've got some burred up strands. Okay, and we do not have a non-conductive cover on this. And we've also got wires touching the cabinet cover. That looks like it's been decommissioned though.